Okay, so it's now coming. 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 All right, all right. Okay, so I think it's now working now. It's been some tech issue. I would like to say that. And but nevertheless, hello all. Welcome to this new video. And today we are on I believe day 4 of our coding journey. So I think we started from like Tuesday. So Tuesday, Wednesday, Thursday, and today is now Friday. So we are on day 4 of our coding journey, and we are coding till we crack something, right? And this will continue on tomorrow because Saturday and Sunday I have to attend some other things. Okay, so I have to learn more about my particular language Java. So I have to learn about OOPS, inheritance, polymorphism, and all those generics and all those things. So I'll be attending a lecture on that. So on Sunday and Monday we are not be going to attending this lecture, right? On Tuesday again, we'll meet for 5 days. Okay, so we'll meet for 5 days again, and then we'll move to another classes, and then we'll move to 5 days again. So on day 5 of on Tuesday maybe, we'll try to finish arrays by today and tomorrow. Okay, so our target and goal is to finish arrays by today and tomorrow. And maybe if we still fail to do it, then we'll try to do it again by Tuesday. So if we are unable to do it, then we are still very late on our track. So our target is to complete everything from arrays till Tuesday. Okay. After Tuesday, that is yeah, after Tuesday, we have two things now more. We have to finish strings first, and then we can move ahead to other things. But we haven't revised anything from now. Okay, so after we finish on Tuesday, we will have a revision session. Okay, this will be a mega session. On Wednesday, we will revise everything what we have learned till now from the perspective of arrays only. After we revise everything on Wednesday, we will shift our focus directly from Thursday onwards and Friday and then Saturday to strings. Okay, so on strings, after we're done, we'll just finish the hash tables as well. So we will be very quick on this. Okay, so we will not just be focusing on something. We'll finish strings first, we'll then finish hash tables. We have some very important algorithms coming on in strings. We have the Rabin-Karp's algorithm, which is a very crucial algorithm. We have the LCS algorithm, that is the least common subsequence, which is another very crucial algorithm, very crucial algorithm. We will write everything, we will understand what it actually is working behind the scenes. Okay, so we will understand what Rabin-Karp's algorithm is. We will understand what uh, LCS algorithm says, and what strings algorithm basically work. But strings, in a most apprehended sense, I would say that they are one of those things that work very well within all those kind of data structures that we have studied till now. Sliding windows is also working in strings. Then we have hash tables working in strings. We have two pointers working in strings. Okay, so all those kind of data structure that we have studied till now, all those kinds of data structure would be working in strings as well. Okay, so it's good thing that we study all those things in a single sense. Just wait a second. Okay, now after we finish strings, let me just see that. Just wait a second, guys. Okay. After we finish strings and hash tables, we have two pointers, prefix sum, and sliding window. So two pointers, prefix sum, and sliding window. We are already, if you are seeing this, we are already doing the sliding window, two pointers, and sliding window, two pointers, and prefix sums. Already in like questions that we are seeing right now. So it's kind of a mixed thing. We haven't done sliding window till now. We haven't done any problem of sliding window, but sliding window is a simple thing. Okay, we'll finish it as soon as we can. So we'll finish these three. Then we have cadence algorithm. I don't think we have much to do here. Then we have linked list. Then we have fast and slow pointers, stacks and queues, and binary search. Okay. Our target is to complete all this by today's what? Today's what? Today is 23. So our target is to complete all this by maybe the 5th of February. Or more recently by maybe 31st of January. Our target is to complete all this by 31st January. Then we'll start trees. Then we'll start the hefty topic of trees. Then it will be the time of basically tough things. Okay, so we will cover trees. We will cover traversals. We will cover the properties and problems. Then we will cover heaps and priority queue. Then we will cover top key elements, intervals. Intervals is most likely the same thing coming up from 2D arrays, but it's still a manageable topic. Then we have BFS and DFS, another very important topic. And after we do this, we will backtrack ourselves by learning backtracking. Okay, so we will learn backtracking. Then backtracking के बाद हम लोग we will do 1D DP. And after 1D DP, if time is still there with us, I suppose we will finish all this by maybe, if God allows us, okay, and we are good on our speed, then I believe 20 February is a good target to achieve this. So we have still around like very close to a month, but yeah, we are still there on the track, because there will be some duplicated questions on this sheet. So we will be able to finish this quite easier, right? After we cover 1D DP, we will be start working on some projects as well. Okay, so we will be working on a spring project, uh, a portfolio project of mine. Okay, so we will work on that, which I have to submit on my college as well, right? So we will work on that. Then we will cover. Then we will do start the job application postings. Okay, so then the streams will be coming. I'll make some videos and more, but on a more perspective, the streams will be end, and I'll just have to start looking for a real job now. Okay, so that's it from my side, and yeah, that's what I wanted to share with all of you guys, the plan, the structure that I wanted to be with. Okay, so our target for today and tomorrow is just to finish arrays as fast as we can. Arrays is a very big topic. There is a lot of questions in array. So yeah, let's finish this as fast as we can. And okay, so let me just shrink myself here so that you are more focused on the things here. Okay, so yeah, okay, and yeah, I think we have discussed pretty much everything. Okay, in the last video we were not able to do this question in our like in the 3 4 questions that we were discussed on doing that, we weren't able to do the rotate image. So we will first do the rotate image today. After we finish rotate image, we will do more sheet questions from the array ones, and then we'll move ahead. Okay, so let's do the rotate image question once. Okay, so rotate image is basically is telling us that we have to rotate this image into the 90-degree. Okay, so so the 1 2 3 here, as you can see here, the 1 2 3 here goes into this part, because the 90-degree of this will be directly from the top to the right part, and then the bottom to the left part. So you have to just remember this. Okay, top becomes right and bottom becomes left. Okay, so bottom becomes what? Left. And top becomes what? Top becomes the right part. Can you see that? Right. So yeah, we are going to have to rotate this image. Okay, so what can we particularly obtain from this particular image, right? We can obtain the particular insertion that the particular properties of mass is that can we try some transpose here? Okay, so do you know what transpose is? Let me just tell you on my whiteboard. Okay, so let's just do what transpose is. Okay, you know what, let's just search what transpose is, because I'm even forgetting what transpose is. Transpose of a matrix. Let's just see transpose of a matrix. The transpose of a matrix is a new matrix formed by switching its rows and columns. The element at position I and j in the original matrix moves to position j of I in the transpose matrix, A transpose or A com. So I don't think we need to do this. Yeah, this one is good. Okay, so if it's a 2 by 3 cross matrix, as you can see here, then the transpose of A transpose T is going to be what? One, it's going to be converted into 3 comma 2. So row becomes column and column becomes row. Can we see that? Row becomes columns and columns become rows. Columns becomes rows, right? So let's just see what the transpose of this particular, what the transpose of this particular problem look like. And there's a problem of transpose matrix. I know it will be very crucial here. So let's just put this over here, and we will use a recursive method call for transpose, and then we will use a reverse function. I'll tell you what it means. Okay, so it is giving us the transpose of a matrix here in this question is, here we have been given a integer array matrix and return the transpose of a matrix. Okay, so let's just solve this particular problem. This is a very good problem to start with today. It's a very, very good problem. Okay. Oh, sorry. Yeah. To this new video. So everything what we have learned till now from the perspective of arrays only. After we revise everything on Wednesday, we will shift our focus directly from Thursday onwards and Friday and then Saturday to strings. Okay, so on strings, after we are done, we'll just finish the hash tables as well. So we will be very quick on this. Okay, so we will not just be focusing on something. We'll finish strings first, we'll then finish hash tables. We have some very important algorithms coming on in strings. We have the Rabin-Cox algorithm, which is a very crucial algorithm. We have the LCS algorithm, which is the least common subsequence, which is another very crucial algorithm, very, very crucial algorithm. We will write everything, we will understand what it actually is working behind the scenes. All right, guys, sorry. Okay, so I think you have been hearing my stream again. I'm sorry. So, okay, let me just think of it. Okay, so I'm here. Hmm, hmm. All right, let's just see what it means here, right? Let's just see. Okay, let's just particularly understand what this particular problem is asking us, right? And then we can move ahead. Okay, okay. Bear with me. Bear with me. Bear with me. Okay. So in this question, let's see first what the transpose is. Then we can apply this particular question into a the rotate image question that we are supposed to do. Okay. So let's see. Okay. Huh. Hmm. Okay. Okay, guys. Okay. Transpose is going to be and 10, 5, 11 and 18, 7, 6. Okay. Row becomes column. Row becomes column. And what columns becomes rows. Are we not doing it? This is what exactly what it means. So the rows here, this row, the color is not hiding. Oh, I'm sorry. Okay. Yeah. Let me just take another color. So the row here. So the row here in this direction. Okay. All right. Okay. Okay. So listen to me very carefully now. Okay. Paste and just fucking keep it here. Okay. Now carefully see that. Carefully see that. The row here. Oh. Hmm. Let me just zoom it for you guys. Uh, oh God. Yeah. Hmm. Okay. The row here becomes what? It becomes the column. The row here what becomes? It becomes the column. And the row here what becomes? It becomes the column. Can you see that? Can you see that? Okay. Can you see for particularly? Just tell me that. So what it is becoming right now? We are transposing. Transposing is basically means we are converting a row into a particular column. That's what it means. That's what it means. Getting my point? The first row will become the first column. The second row will become the second column. And the third row will become the third column. Right? This is the first column. And this is the first column. Sorry, this is the first row. The first one that 2, 4 minus 1. And this is transposing itself, or it is telling itself that I want to, I want to convert into the first column. Okay, it says like, okay, want to be converted into, or I want to tell itself ki, I want to get converted into the second column. It says, okay, you know what, you can just transpose yourself, you can convert myself into it. So this is what transpose is. And the third column into the third row into the third column. So row is becoming column and the columns are becoming rows. Can you not see that? We have seen what the terminology means when a row is becoming a column. So the first row here, for the first row here, it becomes the first column. The second row here, it becomes the second column. And the third row here is what becoming second column. Very messy, right? Very messy, I'm sorry. Think of something else. Think here. One more thing. Okay. Yeah, let's see this. Can we say the columns are also becoming rows? So see here. Okay, it's not like coloring. Well, let me just zoom in. So it will become, you know what? It will become more. Okay, now. So if I use, okay, it's not working. Excel. It's not working there. Mushy. And let's just change it to red. Okay, red. Yeah, it's good. Red is good. We'll use red. Okay, now this column here, 2 comma 2 minus 10 and 18, is it not like converting itself into This one, 2 minus 10, 18. And what is it? It's a row. The column in this is telling itself that, I want to become a row. First row becomes first column, and first column becomes the first row. This is what a transpose is. The order of which it was storing itself remains the same. So the row is becoming a column, but the order of what it is, the number of the row and the column is becoming the same thing. It is not changing a bit. It is not telling itself that, I want to like change myself into this part, and let's become the third part and all the no. The first row becomes the first column. That is a standard, basic, and logical thing to do so. Got my point? Getting my point? What I'm saying? Then what are we left with? What are we left with then? Can we not apply this particular thing into a rotate image question? Let's see what the rotate image question is saying, and then we'll move ahead. Okay, let's see what this question is actually asking us. Okay, it's a good question. Kudos to the one who made this. Let's see what the rotate image question is saying this. Okay, let's see it. Let me just shift things here a bit so you can see more clearly. Okay, let's see. It's a very beautiful thing. Okay, so it's like kind of saying into this. Let's not focus here. Okay, let's not focus on. It's like forget this. Forget this for now. Forget this. This exists. Forget this for now. Okay. What I want you to do is focus on this part. This part only. You have to like convert it into a transpose. So I know 1, 2, 3. So let's just directly transpose this, right? We have been given the matrix. So what the transpose of this looks like? What is the transpose of this? The transpose of this is transpose of this is first row becomes the first column, so it becomes 1, 2, and 3, 4, 5, 6, 7, 8, 9. Cool? Cool? Absolutely cool. 147258369. The first row here becomes what? The first column. And the first column here becomes what? Things are being satisfied here. So it's a transpose. And our target now is sorry, 4, 5, 6, 7, 8, 9. Oh, right. And our target is to convert this into this. Can you not see the similarity here? Can you not see it? Like it's like so in front of you. Just we have to reverse the entire matrix, but from the column side. Reverse the entire matrix from the column side. It's what it's saying. This last column, this last column right now here. Let me just use a different column. This last column here, it is coming to the front one. Converted into a transpose. Convert it into a transpose. When it converts into transpose, what it becomes? 5, 1, 9, 11, 2, and 15, 14, 12. Oh. remove this. Yeah. Sorry, 15, 14, 12, 16. Made. And you want to verify if it's right or wrong, then just check the first column in the first rows. If it's on the right place, then you're doing the right thing. 5 to 13, 15, we are on the right crux area because it's now converting into this and this. So we are converted into a transpose. Now I wanted to see something here. Again, reverse the things here. So in the last column here, the last column of this, is it not the last column of this is in the first place of this? The first place of this. The second column of this into the second last into the first second of this. Third column here, that is the second column in the transpose, is becoming the third column of the rotate image. And the first column of this is changing itself to the last column. Like reverse the whole thing. That is what I'm saying. Reverse the whole matrix. Nothing else. Convert it into a transpose plus reverse the whole matrix, but from the column side. Remember, not the row wise, only the column side of it. This is the whole crux of it, the rotate image. Getting my point? Are you like seeing what I'm saying? So the transpose plus so transpose plus reversing from the column side. Reverse the columns, and this will give you what? The transpose of everything. So this entire thing that we did was rotate image. Getting my point? Are you guys getting my point? Okay. This is the whole thing. Now let's code it out. Let's now code it out. We will do both these things. That is a transpose and the rotate image. It's same thing. It's something else. We will just paste the code of transpose here. Then we will paste the code of rotate image here. Okay. Okay. So one more thing is that it is saying that we have to take it into a void thing. So you can take into void thing, but the but it is not saying saying that you cannot take any auxiliary space or anything. So uh, another 2D matrix and do the rotation. Okay, so let's it is what becoming, it is become the first hand. Are you getting my point? Are you getting my point? This this 4 5 6 in the second, 7 8 9 in the last, and then we are reversing everything to the start. What if, what if instead of like transposing everything to the start, we can transpose it from the below? Can we transpose it from the below? Although can we transpose it from the below? Although we were doing it from the top, like we were removing it from the top and then we were transposing it everything. Can we do it from the below? Yes, we can. 7, 8, 9 here becomes what? The last column should become the last row. The last column should become the last row. But we are just changing the formula here a bit, that we are changing it so that the last column becomes the first row. So we are reversing the whole thing from the last column, that the last column is becoming the first row, second last becomes the second, the last column is becoming the first row, second last becomes the second last becomes the first second row, and the first column is becoming the last row. Similarly in here, in this case also, the last is becoming the first, second last becoming the second, third last is becoming the second last, and the first is becoming the last. So we can do that also. But you know what, let's just first allocate the particular thing inside an array or something, a 2D array, and then we'll just transpose it into another hand. Okay, so let's do that first. Okay, let's not think much of ahead of us. Okay, let's first learn what the transpose of it is and then we'll do ahead. So we are on the Macarena repository here. Okay, we are on the Macarena repository. Last video we also did some questions on product except sales. This was a very good question, but I have a new solution for this. I'll discuss it on that too. Okay. Okay, so let's discuss it. Let's just remove this. Okay, let's double shift, and then we have rotate image, rotate array. Can we also have a transpose image question? No, we don't have a transpose image question. So we have a rotate image. Okay. We will create two things. src dot. We will create two things here. I will tell you what is the transpose of it. Okay. We will do the transpose also. So I'll just paste it over here. Let's just clean some code here. Okay. We have to return an array, no, so we will just copy back things on the right hand side. I don't have anything much to say of here. It's saying that do not use the auxiliary matrix. I do not care a bit. Well, use the auxiliary matrix for now because I want to learn things. Okay, so we are not like pro developers. We will go from this to the next step. Okay, getting my point. So we are on the matrix. It's giving matrix. Okay, it's giving matrix, and we'll do the similar thing. 1 comma 2 comma 3. Okay, 4 comma 5 comma 6, sorry, 4 comma 5 comma 6, and then we have, yeah, same. Okay, so tab, yeah, tab. Okay, and we'll have to rotate the image, no, so we'll have rotate. Okay, so we have to like put static here as well because it's a static class. Okay, so we have to take static public void. Okay, so now we have a rotate function, and in the rotate we are calling the matrix function, and then we are just printing the matrix. Okay, so for int I is equal to matrix dot length, for int j is equal to matrix dot length, and we have to like print this out of it. Okay, we are printing this out of matrix. Okay, now we will calling two functions here also. We will be calling two functions here. We will be calling uh static static int and double cross here, and we will be calling a transpose function, and we will be calling a transpose function and in cross matrix here. Okay, and we will be calling return new int matrix dot length or matrix dot length. Okay, so for now it's good. Then we will also call a reverse function matrix, but we will do it on the same hand. Although we can call a recursive call, and then we can just uh, commit into transpose function. We have to just swap the columns into one another. But for now it's good. Okay, so we'll just remove the transpose function now. The thing here is that we have to remember everything is rotate image is what it is, transposing It is what, transposing plus, you know what, it is transposing plus, um it is transposing sorry, just did this, okay. So it's transposing plus reversal of every column, reversal of column. Okay, cool now. Got my point? Okay, so we will calling a transpose function here, and we have to call the reverse function out of it. Okay. Now let's just find the transpose of it. Okay, so int new int trans is equal to new, you know what, let's just use int nnm also. int int n is equal to matrix and int m is equal to matrix 0 dot length. It's good. And new, we'll be calling a new int nnm. Okay, so this is good. Okay, so we will be calling this, and then we'll be doing this. Okay. Okay, now we have to use the transpose function of it. So what was the transpose function doing here? The first column becomes what? The first row. Here, this image. First column becomes what? The first row. And first row becomes the first column. Okay, so we will be doing the first column and the first row. So int call is equal to 1 and int row is equal to 0. Just defining two variables. Okay, let's just move this. Let's use this. Let's just use two for loops here. Let this thing will become much more easier than this. And for j is equal to this, then I know the trans of j of I is becoming the matrix of I of j. This is the basic thing, right? This, look at this. What is this here? 0 0 0 0. It's becoming what? 0 0. This, see here, 0 1. It is what becoming? It is 2 0. And this is what? 0 comma 3. And it's becoming 3 comma 0. So j of I is becoming what? I of j. Sorry, I of j is becoming what? J of I. See it here in this 18. Let's see 18 here. Okay, 18 is what? 3 comma 1. What is here? What is it here? Sorry, I'm sorry. It's 3 comma 0. No, it's 0 0 0 1 0 2 1 1 1 1 2 1 3. Wait, what is the sorry, sorry, matrix coordinates notation, I think, right? So stupid, so stupid, so stupid. Where is this? Where is this? Yeah, yeah, I'm sorry. This C111213. Okay, so see here, 1 1 is becoming what? 1 1, not changing anything. 1 2 is becoming what? 2 1, and 1 3 is becoming what? 3 1. So j of I is what becoming? J of I is becoming I of j. So can I say that j of I is becoming what? Matrix of I comma j. Simple. Simple. Doing nothing else. And you have to just return what? Trans. Let's just see it. Let's see here. J of 0, I of j, m, j of 0, j plus plus, matrix of j of I is equal to matrix of I of j. Okay, it is giving me bound of outs because index 2 is out of bounds for 0, solution transpose. Okay, okay. Let's go back to the solution here. What are we doing here? I think it's going to be I. Okay, it's giving me I. Okay, so let's just see what the transpose of it's becoming, right? So for I int I of 0 in j of 0, and then we'll do int transpose, you know what, let's do one thing. Let's do one thing. Okay, let's do one thing. Just for checking purposes, okay, just for the checking purposes, let's we have copied this thing, no? So let's just kind of put it into default comments, and I want to just see something, and remove the trans because it's a void function. We don't need trans and anything, and remove this also. Okay, so matrix of I of j, matrix of g of I becomes a matrix of I of j. Let's just see what it brings here. Yep. Just wait a second, guys. Let's just see. It's giving me 1 2 3 2 5 6 and 3 6 9. What? Where's the 4 here? Okay, so it's giving me some problems here as well. Okay, so let's just see again. Okay, our initial thing is we have to use some kind of I here. Okay, so when it's going to be on 0, it's going to be on 0 as well. Okay, 1 2 3 2 5 6 3 6 9. What about if I use I plus 1 here? 1 2 3 2 5 6. Okay, so it's going some problem, going to be giving some kind of problem here. So matrix of G of I is giving to me matrix of I of j. Let's just remove everything. Hmm. Let's see. So matrix of I of j is becoming what? Trans of this is becoming what? And if we just come out of the for loop, uh, let's do 0 here. And yeah, trans of j of I is becoming what? Trans of I of j. So matrix of 0 comma 0 is equal to matrix of G, 1 comma 1, it's becoming what? 1 comma 1. Matrix of 2 comma 2 is becoming what? 3 comma 3, right? So it will never go out of bounds. So for int I is equal to 0, I less than n and I plus plus, j is less than plus plus, and we will be converting into it everything. So I think we can just convert it into here. So matrix I of j here is equal to trans of j of I. Let's just see here. 1 2 3 4 5 6 7 8 9. 9, not this one. You have to see the trans now. And transpose matrix, and yeah, it's giving me index out of bounds. Array index out of bounds. Oh Jesus. Okay, so why is giving me this? Okay, let's just see here. Any problem you're facing, always use a debug pointer every time. Let's just see. Oh, there's no calling function here, no. So we'll use that calling function. Okay, so we call a transpose of matrix, and return value of the method is never used. I know, I know. So let's use a transpose function here. All right. So n is 3, m is 3. Now for I 0 and j 0, then matrix of I comma 0 is going to be what? Transpose of j comma I. J comma 1, 0 comma 1 is becoming what? Okay, 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 okay. Now what the transpose of I is looking out to be? C000. Trans of I. It's giving me 000 of now. Okay, 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 okay. So transfer 3 comma 0. It's not placing values anything, क्योंकि हमने गलत डाल दी है वैल्यू. हमें यहाँ डालनी चाहिए थी. Matrix of I comma j, and then we have to debug it again. Let's just see here again. Okay, 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 okay. Okay, 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 okay. Now let's see what the transpose is looking like. 140. Okay, 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 okay. Transpose is looking like, okay. Transpose is looking like 147, 258, and 369. 147. Where is it? 147, 258, and 369. Okay, so the transpose is working, right? Can you see now? This is working so good. Okay, so transpose is working good. Hmm. And then what? What's happening? Return trans. After it's finished, it is going to return trans. So this is going to be working. Then why is it not accepting things? This stupid thing. Okay. So let's see. Why is it giving me array out of bounds exception? It's working on my system and so well. Is it because, so I have not taken the thing of so I should have to take that case also. if n is equal to m, नहीं, if n is equal to 1 or and m is equal to 1, return matrix, right? This is so stupid, right? This is so stupid. Oh, I got it. Transpose is going to be what, 3, 3, right? हमें मैट्रिक्स के वो भी तो ध्यान रखने हैं. अगर वो 3, 3 से 2, 2 हो गया, स्क्वायर मैट्रिक्स नहीं हुई तो okay, so it should now work. This should now work. Yeah, found it. Okay, yeah, let us submit this simple question now. Okay, sounds good. Now let's go into our question. Now we have called the transpose matrix of here, and now we have to just reverse the whole thing. Okay, so after calling this, we have to call the transpose matrix here. Then what we can do is we can just reverse the whole thing. Okay, so let's just call the two loops again, this and this and this. Got my point? Not trabs, it's going to be trans. All right, and this too, very important. All right, and we have to just call matrix of I of j is going to be what? Trans of I of j, I of j. Let's just see run. Okay, let's just see it, what it brings here. 147258369. Got it? So the matrix is what we know. It's called, it's transposed. It's transposed. So system.array copy transi matrix size 0 to 0. Okay, so this works as well. Now we have the transpose. Let's reverse the columns. Got it? Got my point? So let's call a new function, and we will call it reverse first you have to create a new static variable. So static, public, and the return type is going to be void, and we'll name it reverse int of matrix. So when we have int matrix here, int matrix dot length here, int trans is equal to transpose of matrix, this and this, then matrix of I is going to be what? No. We have to um, reverse this from the column side. So the columns are going to be like 1 comma 2. It's becoming what? 1 comma 2. So let me just see it. Okay. So if we have, after transposing, we will have to bring this into this part, right? So the last columns here, it is what? 7. Huh? So 7 is what? 1 comma 3. So 1 comma 3 is becoming, so 1 comma 3 is becoming 1 comma 1. And 2 comma 3, 2 comma 3 is becoming 2 comma 1. 2 comma 3 is becoming 2 comma 1, and 3 comma 3 is becoming 3 comma 1, is becoming 3 comma 1, and 1 comma 1 is becoming 1 comma 1 is becoming 1 comma 3, 1 comma 2, 2 comma 1 is becoming 2 comma 3, and 3 comma 1 is becoming 3 comma 3. So the first rows are becoming the last columns. So it's I and j plus 2, and the last are becoming j minus 1. But if we come from here to this and swap this all places, okay, let me just think of something. So uh let's not call the transpose here. Matrix of I comma j is becoming n minus j minus I. Can we say that? So j comma I, suppose it's 1 comma 3 here, okay. J comma I, okay, so 0 0, we put here. So 0 comma 0 is becoming what? Minus 1 comma I, so it's becoming array out of bounds. It's not good. And I think it's going to be I into j plus 2. hmm? We have to call the reverse of matrix, and then we have to return this. So let's just run this. All that will give me array out of bounds, I know. Yeah, it's giving me index out of bounds. I know why, because we cannot do this directly. Okay, we have to convert it into something. Okay, let's just let's take two pointers. Let's take two pointers. No. Let's take two pointers. Yes, let's take two pointers. Can we take two pointers here? Yes, we can. We can do anything. Okay, let's take two pointers. Int p is equal to, int p is equal to 0, 0, and int call int yes, and we don't need the for loop as well for this. Okay, now we have to just check that while I is q is greater than p, or we can say, just reverse the whole thing, right? So when while p is equal to q, then what we have to do is int temp is equal to matrix dot p, matrix dot p is matrix dot n minus p, and n minus p is equal to q. This we have to just swap it. That's what the logic was, and then we can just run it. Index 9 out of bounds for length 3, where it is giving me in line number 26. Okay, so int temp is equal to matrix p comma q. So P comma Q is what? P comma Q is what? The last one, and that is 3 comma 4, maybe something. So 1 and 7. So I've taken let me just see it. Let's just see two things. Okay. So it's taking 7. Okay. So int temp is equal to what? 7. Int temp is equal to 7. Int temp is equal to 7, and temp is equal to n minus 1 minus p, that is 3 minus 1 minus 0. No. Yeah, yeah, yeah. 3 minus 1, that is 2. 2 comma minus p is equal to 3 comma minus 3 comma 3 minus 1, that is 2. 2 comma 3. So matrix of um 3 comma 1 comma 3 is becoming what? 2 comma no, that is not becoming the case. We have to put it into the first sense. So n minus j, n minus m minus p. Okay. Hmm. So this one code is good. अरे ये तो वैल्यू डाल दिया यार मैंने. Done. Happy. Call the reverse function, and every time we do it we just use this. So yep. Okay. So that's what the question was asking us doing. Let's just copy this and the transpose as well, and the return transpose, and this as well. All right. And we'll come into this, we'll come into this, and then we'll just copy the whole thing. Yay. All right. Let's just format this as well. Okay. So now let's format this. Okay. It's getting formatted. Yep. All good. Although we have done we have taken an extra array here, we can do the same thing on the matrix array as well. But it's still a very good solution. Can you see it? So we have taken 3 function calls. let's just rewind this again. We have taken three functions call. The simple, the normal function call, then we have the reverse function call, then the transpose function call. Transpose should be above this, but let's put transpose above because transpose was doing the first thing. Getting my point? Transpose should be above everything. Huh. So the first is transpose function call. Transpose function call के बाद we have the reverse function call. So reverse function call was doing nothing. It was just transposing it to left and right. So first we have the transpose I comma left, that is 0, 0 comma 0 suppose, and the 0 comma 0 is going to go 0 comma right, and the right is going to temp. So left and right. Okay. So m minus 1 into left and right, right. The simple function calls for reverse. Okay, we know reverse. We are doing this for a long time now. It's two pointers basically. Then we have rotating image called transpose by reversal column, and we have the transpose, and let's reverse the columns. That's simple. Okay. So this one is done as well. Okay. It's a good solution. It's a good question. Very good question. Okay. Rotate image. Yep. Let's do another question. Let's do another question. Let's do chocolate distribution problem. I know this question is from maybe Code Chef. Chocolate distribution problem. Let's just ask this. There is a chocolate distribution problem in a DSA sheet. Is any lead code problem of this? Hmm. Which was the chocolate distribution problem? Chocolate distribution problem. And today आज तो इंडिया का मैच भी है वैसे. अच्छा ये वाला क्वेश्चन है. Each value represents the number of chocolates in a packet. Each packet can have variable number of chocolates. There are m students. The task is to distribute chocolate packets to among each student so that each student gets exactly one packet. The difference between the maximum number of chocolates given to a student and the minimum number of chocolates given to a student is minimum. And return that minimum possible difference. Okay. So we have 3, 4, 1, 9, 56, 7, 9, 12. M is equal to 5. Okay. So we have to give like we have to distribute. Okay, we have 5 students. Okay, the minimum difference between maximum chocolates and minimum chocolates 9 minus 3. What the minimum difference between maximum chocolates and minimum chocolates? Just wait a second, guys. Uh, just wait a second. ओ लाइट चली गई है। गाइस लाइट चली गई है। सो लाइट चली गई है बट अपनी मेहनत नहीं रुकेगी। करेगा। Now you don't you worry about my boyfriend. Your name is Nicolino. जैसी लाइट आती है we'll back again. Now you don't you worry about my boyfriend. The name is Micorino. 9 minus 3 is equal to 6 by choosing the following impact of 3 over 9, 7, 9. 7, 3, 2, 4, 9, 12 is equal to 3. To different intervals. क्वेश्चन अच्छा है, समझ नहीं आ रहा लेकिन। Macarena, Macarena. Now don't you worry about my boyfriend. The name is Macarena. No, what was I supposed to do? He was a man. And his friend was so. Io Macarena, fai quantena mia che io Macarena. Macarena. Macarena, hi. Que ne cuenta una mia que io Macarena. 341956 3419 3419 567912 56 7, 9, 12. 6, 7, 9, 56, 7, 9, 12. 3, 4, 1, 9, 3, 4, 1, 9, 56, 7, 9, 12. Okay. And then we have south, new chocolate distribution, 5 minute index, and 5. Return 0. Okay, so now we have to solve. Hmm. Now, who was I supposed to do? Who was in the town? And his friends were so fun. नहीं हमें उल्टा क्यों चलना है सो अगर हमने इसे सॉर्ट कर दिया सो अगर हमने इसे सॉर्ट कर दिया तो 9 - 3 We are back. ज्यादा कुछ नहीं करा है मैंने अभी तो। One, two. क्वेश्चन था, साइक्लिक सॉर्ट था ये, याद आ गया वो, मैंने जानबूझ के लगाया है क्वेश्चन, देखना नहीं करिए आप सभी को। So when nums of I is greater than 0 and nums of this is classic cyclic sort. Classic cyclic sort. Very good question. Really good. Cool. But we did this out. Okay. It's oh. तो कल ही करा था, अच्छा क्वेश्चन था। 5 अप्रोच करी थी इसमें, याद होगा आप सबको। लास्ट में हमने क्या करा था, 4 here. So we were switching this particular into negative, and then we were turning into everything into negative. And the first value that was not negative. Okay, so example 2 here. Okay, so 2 was going to be on this place, so we turned this negative and we traversed into this part. So when we reached 2 here, we already seen that this was already negative. So when we see that it's already negative, we found one duplicate, so we added into the list. Yeah, this is what we were doing. You see here we have the int val is equal to math.absolute nums.I. So we have the value here. Now what was the index here? Index would be the value minus 1. For example, if the index value is 4, then the index would be what? 3, because I minus 1 is good to the index, no? So if nums of index is less than 0, then rest would add well, and if nums of अगर nums of index होती है वो 0 होती है तो फिर वो डाल दो उसमें वैल्यू, अगर नहीं होती तो फिर उसको नेगेटिव कर दो। So got my point? Yeah, this is what we're doing. So it's a cyclic sort. Negate. See, I would have written it also. I've also returned it. Negate cyclic sort. Negate what is present in the position you will find ahead. Imagine you have a switch which you can only turn once and not again and again. Cyclic sort helps in this case by marking. Wait a second. Cyclic sort helps you to turn it again and again, and cyclic sort helps in by marking indexes to negate in the sign. Got it? So this was also a good one question. We did this also. If the question was to asking without the particular auxiliary matrix, then it would be very easy. Now remove duplicates from a sorted array. Remove duplicates from sorted array. We did this also, by the way. It's a 2-pointer question. Oh, we didn't do this. Okay. So this question allows us to use the concept of 2 pointers. And yeah, okay. Okay, so this is a 2-pointer based question. We'll do this first. Let's mark questions. Okay, let's mark the questions on what we're going to do next. We did not do rotate array, so we'll do rotate array as well. Rotate array need code. Okay, we'll try to do this one also. I think we did this, but we did rotate image, not rotate array. Yeah. Oh, okay. This one is a very cool question. I'll explain you what this question is. It's a very cool question. Very cool question. Beautiful question. Okay, number of zero field array, increasing triplet by sign, increase triplet subsequence, na. Set matrix zero, na. Word search, word search, word search, lead code. I think you hard wala question. Oh, given an eminent grid character, true, return true if the word exists. The backtracking question, na? not do this question for now. औकात के हिसाब से चलते हैं. Okay, so rotate array, forget it. Arbitrary weights, que sumas que durase que durase Numara levantore numava Holy shit. Okay, guys. So this is for today, and we'll continue more tomorrow. And yeah, on our target, we'll finish with this. Tomorrow we will do first with this question, majority element two. Then we have a lot of question here. We have like 23 questions here. So let me just like paste it here. Let me just like paste it somewhere. Yeah, let's paste it. Yeah, the cloud will save everything. Oh, sorry. Hmm? Let's paste it here. Okay. So we have these questions: union, intersection of sorted arrays. Then we have to do this. Then we have cyclically rotate array. Cyclically rotate array. Oh, I guess this is the one thing. Cyclically rotate array. So I think we have done this also. Cyclically rotate array is kind of same with what rotate array is. Let me just confirm. Is cyclically rotate array and rotate array the same? Yeah, so we have done this. So let me just update it. Cyclically rotate array. Yeah, this one. Hmm. Yep. Okay. So we have this. Then we have this rotate array by one. So it's also a good question, but we have done this previously, right? We just have to just remember the thing. Okay, just we have to just rotate it by one. So we don't have to like do anything else. We don't have to like reverse and all those things that we were doing it, right? So we can do the reversal. We can do the reversal because we have to do the reversal. It's nothing like but the k is always going to be one, so it doesn't matter, to be honest. Okay, so we can do this. It's a basic question, so we can do this tomorrow. So I'll just put this here as well. Okay, we'll just revise everything. Okay, then coming back to here, then okay, so this is kind of done. We'll just okay, minimize maximize difference between heights. We'll do this, right? And word search, I think the BFS algorithm, कुछ DFS algorithm इसमें आ गई हैं जो हमें नहीं आनी चाहिए थी, बट कोई नहीं, हम वक्त के साथ देखेंगे. सेट मैट्रिक जीरोस, ये मैंने बहुत सुना इस प्रॉब्लम को, कल इसे भी देखते हैं पहले तो. Given m by n matrix, set its entire row and columns to 0. You must do it in place. If an element is 0, set an entire rows and columns of it to be 0. You must do it in place. Okay. Hmm. Okay. So if there is a 0 here, then I have to just transform everything into its 0. Okay. A straightforward solution using MON space is probably a bad idea. Simple improvement uses m plus n space, but still it's not the best solution. Can you devise a constant space solution? Okay. If any cell on the matrix we can record its one column using additional memory, but if you do not want to use extra memory, then you can manipulate the array instead. Example exactly. Setting cell values to 0 on the fly while iterating might lead to discrepancy. What if you use some other integer values markers? There is still better solution. We'll do this too. It's a good question. अभी समझ में नहीं आ रहा मुझे 1% भी. And we'll do the rest. Okay. So yeah, that's it for now. Tomorrow we'll start with this. So yeah, thank you again for coming, you all. And yeah, let's meet tomorrow. Okay. Let's just refresh it and just back it up. we're close to 1,000 contributions as well. So yeah, it's a good achievement, right? Yep. All right. So thank you all for coming. Bye.